For Module 2, we are also going to take a look at Section 12 of Chapter 3 on chemical nomenclature. From this, your learning outcomes are to be able to determine the charge on common ionic species using the periodic table, recognize the difference between binary ionic and covalent molecules using the periodic table, name binary ionic compounds using IUPAC nomenclature rules, name binary molecular compounds using IUPAC nomenclature rules, be able to determine ionic species in compounds and containing polyatomic ions, memorize the name, formula, and charge of common polyatomic ions, name ionic compounds containing polyatomic ions using IUPAC nomenclature rules, and name binary acids and oxyacids using IUPAC nomenclature rules. There is a structural relationship between monatomic ions and the periodic table. First, let's talk about the structure of the periodic table. It is arranged by increasing atomic number. The atomic number is usually given in the upper portion of the box containing the element, along with a 1 or 2 letter symbol for the name. Now, there are parts to the periodic table that the majority of the table are what we call metals. Okay? So those are in blue. The nonmetals occupy the right side of the periodic table. These guys are in yellow. Okay, you can see there are much fewer nonmetals. And then we've got a series of metalloids. These are things that are metal-like. Okay? They are metal-like, but they are also like nonmetals. Metals are shiny, they are malleable, which means you can hit them with a hammer, and they are ductile. Nonmetals tend to be the opposite. They are dull, and they are brittle. Non-metalloids are somewhere in between. Some are shiny, but some are brittle. Some are malleable, but some aren't. Additionally, metals are good conductors of heat and electricity. Nonmetals are poor conductors of heat and electricity. And metalloids are semiconductors. They don't pass it well, but they will allow it to pass. Now, more about the structure of the periodic table. There are numbers indicating the columns on the periodic table, and there are numbers indicating the rows. The columns are called families or groups. And then the rows are called periods, hence the term periodic table. Now, there are several different ways that we can number the columns. This one shows the newer version where we number the columns 1 through 18. Older versions of the periodic table will use the A-B system, where this is Roman numeral 1A, Roman numeral 2A, Roman numeral 3A, 4A, 5A, 6A, 7A, and 8A. And then these are the B's, and we're not going to worry about the B's. It's the A groups that I want to talk about in particular because these are relatively easy to remember ion charges. So we're first going to talk about cations, and we're going to talk about group 1A first. Group 1A forms +1 ions. This group is also known as the alkali metals. So if I say, what is the charge on an alkali metal ion? You would say +1. Let's talk about group 2A now. For group 2A, these guys are known as the alkaline earth metals, and they form +2 ions. Okay, so group 1A forms +1, group 2A forms +2. Now we're going to move all the way over to what would be group 7A. Group 7A are also known as the halogens. Halogens tend to form -1 ions. These are anion forming. So metals tend to form cations, anions are formed from nonmetals. So group 7A, the halogens, tend to form -1. Group 6A tend to form -2 ions. Group 5A would tend to form -3 ions. There are also a few ions that you need to know because they're only going to form one cation type, and that is silver forms a +1 ion. Zinc and cadmium both form +2 ions, and aluminum, gallium, and indium all form +3 ions, which is kind of an easy way to remember it because there's 1, 2, 3. 1 forms a +1, 2 forms +2, and 3 form +3. These are important to be able to recognize the monatomic ions and their charges from the periodic table, because all the rest of the compounds that we're going to deal with that contain ions can have variable charges. And that charge, that variable charge on the cation needs to be determined based upon the anions. So let's remind ourselves, metals combine with nonmetals to form ionic compounds. Then we can combine nonmetals with nonmetals to form what we call molecular compounds, molecules. And only 2 elements combining, we call that a binary compound. Now that's 2 elements, not 2 atoms, 2 elements. So for example, water, H2O, is a binary compound. Sodium chloride is a binary compound. Okay? For the nomenclature for each of the types of compounds, I have made individual videos over the past several semesters dealing specifically with each type. Now these are the types that Zumdahl discusses as being type 1, type 2, and type 3 compounds. Type 1 is where you have a binary with known cation charge. Type 2, binary with cation of variable charge. And type 3, binary there we go, non-metal to non-metal, or molecular compounds. In addition, type 1 and type 2 can contain polyatomic ions as well, and those videos are also discussed, as well as the nomenclature of acids.